Yes. So, okay. So the formula for 30 degree, 30, 60, 90 is n root 3 2n. So if 2n equals 1, I'm saying that because the 1 is labeled on the 2n side. Divide by 2, n equals 1/2. And then this one is going to be 1/2 root 3, but we don't write it like that. We multiply the root 3 times the 1, and it's root 3 over 2. Okay, so this is what I want you guys to do. I want you to take your sides, so this is root 3 over 2, and I want you to label them inside. So 1/2 root 3 over 2. Okay, and then I want you to put a 60 here. Make sure the whole thing is labeled. You have, because we're going to cut this out, so you need to have all three sides and all three angles labeled. Okay, 45, 45, 90. These are both n because they're the same. And then this is n root 2. And n root 2 equals 1 because that's the one that's labeled. Divide by root 2 on both sides. Get n by itself. However, we can't leave a root in the bottom, so what do? Beautiful. Multiply by a giant one made of root 2. And this comes out to be 1 times root 2 is root 2. And what's root 2 times root 2? Yeah, root 4, which is 2. Okay, so the good news is both of these things are the same. This is root 2 over 2, and this is root 2 over 2. I wondered how you got that in that homework question the other night, Mrs. Alvin. Yeah. Okay, and now label this up here. Make sure that all three sides are labeled, all three angles are labeled. Okay, next thing I want you to do is cut these out. Okay, we are going to recycle the rest of the paper, even though that it has the math on it. Please do not wad it up and put it in the little baskets. Thank you. Okay, now once you get your triangles cut out, what I want you to do is flip the triangle over and make sure the other side is labeled the same way. So you're gonna have to like look through it. So make right angle. Make sure that both sides of your triangles have all three sides and all three angles. Okay, and then when you're ready, bring those over to your green unit circle. Pass the unit circles out to everybody. Okay, so we're gonna label this whole thing. This is problem 72 through 75 is doing this, but Miss Rice and I like to do it in an arts and crafts fashion because we think it's more fun. That's why we have the triangles. It also helps reinforce about reference angles and things, and also about the quadrants. So we're gonna start first by talking about the quadrants, which might help you if you need help with the Pythagorean identity problems. This is quadrant one. And the cosine is positive and the sine is positive. And up here, let's make ourselves a little key. We're going to say cosine equals x, sine equals y. Just so you have those little references up there. Cosine is x, sine is y. And in quadrant one, both x and y are positive numbers. Are you guys with me so far? Okay, now let's go over to quadrant two. And if I am graphing a coordinate and I go back and up, is x positive or negative? Negative. So that's cosine is negative. And is sine positive or negative? Positive. Okay, now scroll down to quadrant three. These coordinates are all going back and down. So both cosine and sine are negative. And then quadrant four, these coordinates going forward and down. So cosine is positive and sine is negative. Okay, and I'm hoping that that will help with your Pythagorean identity problems. Just like going over that one more time. That's not what we're doing here, but it helps. Okay, now we're going to label some stuff that we know. We know this is 0 degrees because this is where everyone gets on the screamer. We know that this is the coordinate 1, 0 because the radius is 1. That's why it's called the unit circle. You guys okay? Okay, now go straight up to the top. We know that this is 90 degrees. And this is the coordinate 0, 1. Over here, this is 180. with the coordinate -1, 0. Then go to the bottom. This is 270 with the coordinate 0, -1. Are there any questions about those very basic guys right there? I'm hoping we're good with those 4. Okay, now go back up here to quadrant 1 and take your 30, 60, 90 triangle, and you've got to rotate it around. So Miss Rice and I made these so they fit perfectly into this unit circle. So you might have to rotate it around a little bit to make it fit. Okay. What is the reference angle in this particular spot? What's the reference angle in this spot? 30. Okay. Remember, reference angles are always in quadrant 1, positive numbers. So that means we know this spot is 30 degrees. And we're going to get the coordinate next by using the sides of the triangle. So when you graph a coordinate, you go over first for x and then up or down for y. So the coordinate is √3 over 2, 1/2. You guys see how it was graphed? Like over and up. That's how you graph a coordinate. Are you guys with me? Because we have our triangle labeled makes it better. Okay, now grab out your other triangle. And tuck him in to the next spot. What is the reference angle in this spot? 45. Great. Okay, and the coordinate goes over and up. So √2 over 2, √2 over 2, over and up. Okay, now get your other triangle back out, and you're going to have to rotate it around so that it fits right here. Okay, what is the reference angle in this spot? 60 degrees. Great job. And what is the coordinate? 1/2 √3 over 2. Okay, now we're going to go over to quadrant 2. And you can use that same triangle you just had, just reflect it across. It's not going to take so long. Okay, I'm going to ask you 2 questions now. What is the reference angle in this spot? What is the reference angle? 6. Shh. The reference angle in this spot is 60. When I say reference angle, I need that to be between 0 and 90 and positive. The reference angle is 60. Now, let me ask the question that Connor just answered. What is the actual degrees right here, though? 120. The angle from 0 is 120, but the reference angle is 60. Okay, now what's the coordinate? Be careful what you say. Nice. Negative 1/2 positive √3/2. Can't get anything past Gershon. Now do you see why it's not going to take that long? Because they're just the same exact thing. You just have to be careful of the positives and negatives. Okay, so get out your next triangle here. Okay. See if you can answer this correctly. What is the reference angle in this spot? 45. But what is the actual angle from here? Nice. Reference angle is 45, but the actual angle from 0 in standard position is 135. Okay, and then my coordinate, negative √2 divided by 2, positive √2 divided by 2. Okay. Reference angle is 30. What is this angle? 150. And the coordinate is negative square root 3/2, positive 1/2.
Yeah.
Okay, now flip your triangle over. You can head down into the quadrant 3. Unfortunately, the blank is covered up, but you can tell the reference angle is 30. And this is 210. Okay, and then the coordinate. So when you do coordinates, remember it's right or left, then up or down. So these are both negative. Negative √3/2, negative 1/2. Negative, negative 225. Does that make sense? Okay, last one in the third quadrant. Negative 1/2. Negative √3/2. 240. Okay. Last quadrant for this. This is positive 1/2, negative √3/2. What's the reference angle here? 60. And what's the standard angle here? 300. Okay. Now, if table one could stop stealing my fraction thunder. Kidding. Um, we're gonna do the radians then. All of the rest of the blanks are the radians, but it's honestly exactly what they were saying. It's easier if you just know how to count. So if you can count, then you can do the radians. Not that I was eavesdropping. I was eavesdropping. Okay, so let's start with the radians that we know very, like, just from a very basic one. Okay, so we know that this is 0 radians. They get on the ride here no matter what. Everybody should know that halfway around the circle is pi radians. And that if you come back all the way around the circle, that is 2 pi radians. And that is, the very, very basic, most important facts right there. Okay, so now we're going to do some fractions. So scroll up here. If this halfway around the circle is pi, then a quarter of the way around the circle is half pi. Okay, but we don't write half pi, we write pi over 2. Okay, so now what we're going to do is we're going to count by fourths. I want you to ignore the all of the, we're only going to go in the middle of each quadrant for right now. Okay, so we have 0, 1 pi's over 4, 2 pi's over 4. Do you see where the 2 pi's over 4 went? Okay. 3 pi's over 4. 4 pi's. Okay, I'm going to do it again. 0. 1 pi's over 4. 2 pi's over 4. 3 pi's over 4. 4 pi's over 4. Okay. 5 pi's over 4. 6 pi's over 4. 7 pi's over 4. And then 8 pi's over 4 is 2 pi. Okay, now we're going to do the thing that Matthew was doing. Okay, here we go. 0. 1 pi's over 6. 2 pi's over 6. It was Ryan. Was it not Matthew? Okay. 1 pi's over 6. 2 pi's over 6. 3 pi's over 6. 4 pi's over 6. 5 pi's over 6. 6 pi's over 6. Just check the top first before we move on. Seven pi's over 6. 8 pi's over 6. 9 pi's over 6. 10 pi's over 6. 11 pi's over 6. 12 pi's over 6. Okay, a lot of my students like to either like tape or a glue stick or something, these triangles onto the bottom like this. You don't need to know that it's from embeddedmath.com. So go ahead and feel free to either tape or glue stick your triangles onto the bottom. And then get out your packet. Okay, now I'm going to answer this question one time. Pass it on to anybody who's absent. Do we get to use our unit circle or quizzes and tests? No, no. If you have a note card allowed, you have to make it if you want it. Okay. Do we get to use our unit circle on our quizzes and tests? The answer is no. If you want it, you have to make it on a note card. I will tell you, to be honest with you, I have a little bit of sympathy for you, but really not, because if you can just know these, you can figure out the whole rest of it just from sign changes. So really, what I would do if I were you on a note card is I would make quadrant 1, and then I would just put like positive, this is like positive, negative, 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 positive, you know what I'm saying. Anyway, so that's what I would do just to avoid drawing the whole dealio. Okay, now do not put this away. Just scooch it off to the side and find these two problems. This is technically warm-ups, but we're going to call this note, the first two notes. And we're going to start doing these as warm-up. But don't put your unit circle away. You're going to want it still. Okay, all of the values on these first few are on the unit circle, but we're not going to use it for bad. We're going to use it for good. We're not going to cheat off our unit circle. We're going to actually try to understand the problems and not just copy off of what we did. But I still want my unit circle for the triangles at the bottom. So anyway, okay. Starting with number 1, these are now notes. Draw the terminal side, then label the angle on the circle. Okay, so start. Shh. This is 0. This is 3 pi over 3. This is 6 pi over 3. Okay, now yesterday, some people were like, oh no, I don't know how to get this one. You don't really need it. You just need this, and this again. Okay, now the denominator of this is 3. So I like to break my half circle up into 3 equal pieces. It doesn't have to be perfect. No. Denominator's 3. So I have 3 equal slices of pizza on the bottom half. Why am I doing the bottom half? Because I can tell it's 5 pi. If you want to do the whole thing, you can, but I know that 5 pi over 3 is going to be right before 6 pi over 3. Okay, let me go through my process again. First, I put 0. I looked at the denominator was thirds. I put 3 pi over 3, 6 pi over 3, and then I broke up the circle into thirds and went 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Okay, you good so far? Is that better? Okay, now that's step 1. Draw the terminal side, label the angle on the circle. Step 2, find the reference angle and draw the appropriate special triangle. Okay, reference angle is this, which I hope we reinforce today with our arts and crafts. And what we want to do is find the difference between 5 pi over 3 and 6 pi over 3. So I'm going to go up here, 6 pi over 3 minus 5 pi over 3 is 1 pi over 3. So reference angle is pi over 3. Okay. Find the reference angle and draw the appropriate special triangle. Okay, so there's my appropriate special triangle. Okay, now I come over here and I'm like, what, this. If you guys need to convert pi over 3 to 60 degrees in your mind real quick, do you know how to do that? Like just go 180 divided by 3, because you can even think of it this way, just half the circle's 180 divided into 3 equal pieces means those are 60s. Do you know what I'm saying? Okay, so this has to be 1/2. Do you see how I'm using my picture? This is going to be negative root 3 over 2 and 1. And then the coordinate is your final answer, which is 1/2 comma negative root 3 over 2. Okay, now we're going to do number 2. 0, 4 pi over 4, 8 pi over 4. Good so far? Okay, now denominator's 4, so I'm going to cut the circle up into fourths. I'm only going to do the top half of the circle. Do you guys understand why I'm doing the top half only? Well, I could do the whole thing. I'm just lazy, but because where is 3 pi over 4 going to live, right? Yeah. Okay. Reference angle is here. So I need to find the difference between 4 pi over 4 and 3 pi over 4. Which is 1 pi over 4. And 180 divided by 4 equal pieces is 45 degrees. So you know these are 45, 45, 90s. Hint, all of the ones with a 4 in the bottom are 45, 45, 90s because it's 4 equal pieces. Okay, then I find my triangles at the bottom of my unit circle. Almost forgot the negative. So coordinate negative root 2 over 2, positive root 2 over 2. This is not on the quiz. The like finding the triangle? Not on the quiz. Do we need to go over what's on the quiz again? Pythagorean identity, graphing in standard form, so just that first part with the arrow, and then converting from degrees to radians and radians to degrees. That's it. Okay, last thing for the day. First of all, do you guys know the homework is not this. These are going to be warm-ups for the rest of the chapter. So don't do any more of these unless you're just bored. Homework is 76, 77, 78, and 80. But what I want to do is take questions from the quiz to review and the radians, angles, and the worksheet from last night. So if you could find the worksheet from last night, please. I would like to take questions from this, and this is the last thing. If you don't have any questions from this, you can start your homework. Connor. Okay. So first thing I want to tell you is this is where you can pick up the calculator. Oh, no, that's fine. Okay. Okay. So what you do, Connor, is first you make sure that your calculator is in radians. And then you say, okay, I'm going to do cosine of 0 is, yeah. And then cosine of pi over 2. And then I'm not going to do the whole thing. I'm just going to do the first 3 because I want to show you how it looks after the first 3. Cosine of pi is -1. And then what you do is you go, okay, I know this is a wave. So I'm going to follow the pattern. And then I just sketch in. Once you get the first couple, you can establish the pattern and then just sketch in the wave. Just really large pet peeve of mine. Please don't make it look like teeth, like scary monster teeth. This is supposed to be a wave, not supposed to be like, it's supposed to be so. This is not like a bunch of absolute value graphs next to each other. Okay. Do you understand what to do for sine, Connor?
Isn't time start at 0?
Yep.
Right. And then it goes up, right?
Yeah, so you don't even need the calculator. Just okay, next question.
That one on the 22.
It's not on there.
That'd be good.
No, it's not on there. Okay, next question. Anything? You sure? Okay, it's okay. I'll still take questions for individually after Kashan. 32. Okay. I just said, okay, this is negative 13 pi over 6. Then I know this is going to be 2 pi. So it'd be negative 12 pi over 6. It's also positive 12 pi over 6. Both of those. What's the difference between negative 13 and negative 12? 1. So 1 pi over 6. Do you want to do, did you, okay, let's do 15. Okay, we're going to do 15 real quick. Draw a triangle in the appropriate quadrant and then use Pythagorean identity to find the value of each expression. Okay, so this problem says cosine is positive, cosine is x, and sine is less than 0, which means sine is negative. So which quadrant has a positive x and a negative y? That would be quadrant 4. Beautiful. Okay. So because I'm lazy, I'm just going to draw the triangle in quadrant 4 only. Okay. And it says if cosine is 2/5, so that's the x. We're finding sine, that's the y. And hypotenuse is always 1. Okay. So 2/5 squared plus y squared equals 1 squared. 4/25 plus y squared equals 25/25. Minus 4/25 from both sides. Y squared equals 21/25. Square root. Square root. Shh. Does that make sense? Okay. So then you have to choose the positive or the negative, and it says here that sine is less than 0 and you're quadrant 4, so you need to choose the negative one for your final answer. So sine is negative root 21. Oh, and you might want to, if you You're not going to have a calculator though, so think about it like that. We simplify the radicals instead. So 16 is in quadrant one, right? And interestingly enough, you should be able to confirm with your unit circle on this one after you get it done. Because sine is 1/2. It's one of the triangle values.
They read the values on triangle.
Oh, Pythagorean theorem, which gets you most of the way there, to be honest with you. Okay. Any other questions from the homework? Okay, so you guys have the rest of the period to do, what are the problems again? 76, 77, 78, and 80. I know. It's not too bad. I like unit circle day.